Hello, we are group 16 for the analog circuits project. We have tried to implement a water quality assessment system. Uh, the motivation behind this project being that water is one of the most important resources which we have, and it is of critical importance that we are able to evaluate the quality of water. Now, people might say that water quality is a subjective thing, but we have tried to quantify it by using some concrete parameters. The parameters being temperature, turbidity, pH, conductivity, and the total dissolved salts present in the water. We have used individual sensors for computing each parameter, and we have interfaced each one of them with using a Arduino Uno, and we further send the data which we collect from each of the sensors using a GSM module SIM900A. Let me first of all show you the hardware which we have used for the project. Let me take you through the sensors which we have used. This is the Arduino Uno and the GSM module which we have connected with the PC. This is the pH sensor. Next is the ultrasonic sensor, which is this tiny thing. These two strips of aluminum make up the conductivity sensor. This is the temperature probe, DS18B20. And finally, we have the turbidity sensor. Let us go through the working and the principle of working of each of these sensors so as to get an idea of how the project has been actually implemented. Turbidity is essentially the cloudiness which is present in water. So if the water is muddy, if there are a lot of suspended particles in it, then it would be important for us to detect it and tell people not to drink it. So every sensor needs we needed to figure out a way as to convert the physical phenomenon into some sort of measurable electrical property, which so we needed a transducer for that, which basically does the conversion process. So in case of turbidity, the turbidity is directly proportional to the scattering of light. So if the water is muddy, the particles present in it would scatter more amount of light, and hence and that tells us that the water is cloudier. So the basic circuit is that we have used a light emitting diode which sends a beam of light across the water sample, and this is the receiving port. So essentially, as we can see, if the light travels through the medium, and some of the light is either absorbed by the suspended particles or is scattered, and so naturally the amount of light which is received would be lesser if there is more disturbance in the medium, and at the receiving end we have a photodiode which is able to detect the amount of light which it has received and convert it into a corresponding voltage, and that is how we map the turbidity to the voltage, and that is how we are able to quantify the turbidity of water present. One might argue, how is the water level a parameter of water quality? So this was just an extra addition to the overall project. Many times we would want to detect the level of water which is left in a tank. It might be important during during summer when it often happens that the water levels fall below the ideal level. So this sensor works on a very simple principle of this is the tiny thing which basically emits ultrasonic waves which travel at the speed of sound. The basic principle which is used is that we know the speed of sound. We can assume that it is uniform, and our well-known friendly formula, we speed is equal to distance upon time. We've used that, and so basically the sensor emits a sound signal and waits for it to come back. So it is essentially a transceiver. So we measure the time interval which it takes for this process to happen, and since we know the speed of sound, we are able to calculate the water level, and we have written code to ensure that if the water level falls below a certain ideal level, then we trigger a call using the GSM. Next, we have a temperature sensor. It is often important to measure the temperature of water because it's important in industrial applications where, for instance, for a particular chemical reaction to happen, say you need the water to be at a specific temperature. It is also important in pharmaceutical industries where you would want you would not want anything to go wrong with while you are making a critical medicines. So we have decided to use the DS18S20 temperature probe, which is a waterproof sensor. So and it's elongated. It is in the form of a wire. So it is ideal for use in our project because the sample of water might not be close to our actual testing unit, and the waterproof part is obviously important. We don't want anything to get damaged. So essentially, it's a thermistor which is able to uh, compute the temperature and map it to a particular voltage level, and that is how uh, we can measure temperature. So it essentially acts as a thermometer, and it's a one wire device. So separate source. It doesn't need a VCC. It has a parasitic power resistance, so it can essentially power itself when its data line is not in use, and that so the and it also has a inbuilt ADC, so it can directly provide you digital information. So we don't even need an external ADC. Uh, so uh, the only thing which we need to do in our code is to uh, just make sure that the digital it basically returns us information in an encoded format. So the only thing which we need to do is to decode it properly and send it to the GSM. uh, this is our conductivity sensor. uh, Conductivity is closely related to the total dissolved amount of total dissolved salts in our water sample. uh, Conductivity has many industrial applications. Sometimes you would want your water to be conductive. Say if you are in the electroplating business also, and TDS has many important health implications. For instance, if the water has many if the water is too salty, it can have an effect on the gastrointestinal system of humans, and so it is of essence that we prevent people from drinking such water. And uh, in the area around DICT Gandhinagar, the water is a bit heavy. Is a bit hard, and therefore we expect it's when we will show you the readings, we expect that its TDS readings which we get would be on the higher side. So it basically works like a capacitor. A voltage is developed across when we dip these two when we dip these aluminum foils, which have a approximate square area in the sample, some potential is developed across it, and uh, uh, because of the resistances which we have attached in the circuit, there's a voltage divider relation, and so the voltage which is captured between the two areas is we get a corresponding value depending on how conducting the solution is, so the amount of ions which are present in the solution. And so that is how we map conductivity to a specific voltage. And interestingly, we do not need a separate sensor or circuitry to find out the total dissolved salts. There is a simple relation. uh, so if you multiply 0.67 into the proper units, SI units of conductivity, it gives you an idea, approximate idea of the dissolved salt content in water. We had also tried to implement the pH sensor, and as the name suggests, it basically is able to measure the pH of water. So this is a cool looking probe, which and its associated circuit. The probe has a well-known so it basically has a solution whose pH is known, which acts as a reference solution. It's KCl basically, and it has one electrode is dipped in it in the known solution, and the other electrode is wrapped around a special glass which is able to conduct electricity. So the what basically happens is that the hydrogen ions which are present in the solution are able to pass through the thin glass membrane, and the electrode is able to detect its concentration, and that is how we can uh, uh, that is how we can find out the pH of the solution. This is the circuit diagram. It's not very complicated. The circuit, the structure which I was talking about. And finally, we have used a GSM module, SIM 900A. So it is basically like a simple mobile phone which is able to send and receive calls and SMS. And we have used the actual SIM card, and that, so it's basically able to connect to the GSM network, uh, and so the data which we and the data which we collect, we just we establish a connection using code between the Arduino and the GSM, and the GSM does the rest of the job of transmitting it on forward. Let us show let me show you a brief demo of the readings of how this all of these things are put together, and that we actually get an SMS which describes the readings which we have got. So we have set everything nicely, and we the only thing remaining is to give power up the Arduino, and hopefully the message would be all the readings would be taken correctly, and the message would be sent. So let's power this up and wait for it. So it would take around 15 to 20 seconds to perform all the calculations, and we also consider the lag time which in which the message has to be sent and sent by the GSM to the tower, and let's wait for it to come back. We can hear the buzzer or the inbuilt buzzer of the GSM module, so it means that it has received the information from Arduino, and hopefully in a few moments time. There we are. So we have prepared a string, and as you can, we can read temperature 35.81 Celsius. Clearly summer has arrived. Conductivity, turbidity 4.28. So I suppose we are using dirty water. The level is 18 centimeters, which is a bit wrong, and the total dissolved salts is 2.52, which clearly means that the water which we have here is a bit difficult for the stomach. And so thank you guys for watching, and hopefully you liked our ramble. Thank you.
Hello, here we are doing the final testing of our project. So we have integrated the project with LCD also, and we have put it in a box. And this is where we are getting the reading in the LCD, and there is the mobile, and there we got the sound of the message. So the SMS is there with the specifications, and this is the current message, which is showing the current time also. So you can check it. So this is the current time, and this is the current reading of the message. And at the same time we can see the current readings on the LCD also, and you can also tally the readings a little bit with the message. And again the circuit here, with the Arduino, the main circuit, the LCD circuit here, and this is the GSM module along with the SIM card. And here we have a water solution with two of the sensors, visible conductivity sensor and the ultrasonic sensor. And over this side we have two more sensors. This is the temperature sensor, and the other one is the turbidity sensor. So yeah, again LCD and the message. Thank you.